at this. I just decided that we should carry out just one out of the two experiments. So here with me is a powdered milk. Now this is water. This one is a HCl. But there's something I want you to do. I want you to, in the comment section, what is the name of this? This is number one. What is the name of number one? What is the name of number two? This is number two. This paper is number two. What is the name? What do you call this? Number three. And what do you call this? So I would like you to put the answers in the comment section. Let me know, because I've discovered that many students cannot identify the laboratory apparatus. Thank you very much. So we are going to carry out an experiment at the end of this lesson. So join us from the beginning to the end. This is very, 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 very important. Very, 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 very important. Please join us very well. You are going to be happy at the end of this time. All right, look at this. In this qualitative analysis, I've guided you before that what you need to have on the table is this. This is going to be question number 2 in your examination. So you have tests here. Test. Remember to use capital letters. Observation, and inference. Use your ruler. But one thing with NECO, the table is always drawn for you. So now we can continue. Test, observation, inference. So now this is question number 2. So you may have question number 2A. Put this question number 2. Then you can have A. Then the first question. You know what you are going to have will be, you have to carry out an experiment on zinc chloride. You are going to look at experiment on zinc chloride. Generally, I do tell students that if you are good, if you know the cations and the precipitating reagents, you can always fill this table: test, observation, and inference. If you know the cations and the anions and the precipitating reagents and how they behave, then you can always, even without carrying out the experiment. But this one is not common. That's why I decided to carry out this experiment, so that we observe everything with our eyes. All right, so let's look at this. If you are testing, now I've seen that if you are testing for metals, test for metals or cations, you use, these are the ones we use most of the time: ammonia and sodium hydroxide. Use these to precipitate them. But anytime you see acid radicals, that is the anions, the acid radicals, we use silver triazonitrate 5. Use silver triazonitrate 5. Use lead 2 triazonitrate 5. Use lead 2 triazonitrate 5. We use lead 2 ethernate. We use all these. We use these 3. We can use them to precipitate chloride ion, right? We use barium chloride to precipitate SO42 minus. So we use this to precipitate this. We use silver triazonitrate 5, silver triazonitrate 5, lead 2 triazonitrate 5, and lead 2 ethernate. To do what? To precipitate chloride ion, Cl minus. Can you see this now? So these are the reagents for precipitating anions and cations. These are anions. These ones, the ones that have these ones. These are anions. Another one we always carry out the experiment on is this. This one, most of the time, anytime this is involved, we use acid plus the salt. Effervescence occurs. Odorless, colorless gas evolves that turns blue litmus paper red weakly because a weak gas. Turns lime water milky. This is this for this anion. All right. So, but now when you look at this experiment does not involve silver triazonitrate 5. So the test for chloride ion, it has a very big question mark. So this experiment does not, this silver triazonitrate 5 is not involved, neither this nor this. So the test for chloride ion has a very big question mark. It can still come out. If it comes out, at least you know you can still approach it. But let's look at zinc. Zinc is a transition metal. But if I should go further, you will say zinc is non-transitional because it does not have zinc ion. The ion, it does not have partially filled 3d orbital. That is another thing. And zinc is a colorless. While other transition metals, you know, generally transition metals are metals that have what? Partially filled 3d orbital. Their 3d orbitals are not filled completely. Instead of having D10, instead of completing, it will just be part 1, 2, 3, 4, 5. Which means the 4s orbital will be filled first before 3d orbital is filled. So those ones, 3d1, 3d2, 3d3, 3d4, 3d5, 3, all of them are transition metals. And they have characteristics. The ones that are complete, let me call them the full transition metals, have what do we call it? They have colored ions, but zinc is considered non-transitional. It is colorless. Now look at this. So if you carry out, if you dissolve, this is a soluble salt. Why is this a soluble salt? All salts that contain chlorine, all chloride salts are soluble, except silver chloride, AgCl2, AgCl rather, except silver chloride, lead chloride. These two are what? Insoluble. Then if so, which means that is why most of the time we use silver and lead to precipitate this. So zinc chloride is a soluble salt. If you dissolve it in water, it dissolves. So you can say C plus water, right? Because it's a soluble salt. You say what? Salt dissolves. Salt dissolves. So if you test it with litmus, because this is a strong, this component is a component of strong acid. If there's litmus plus litmus, it will surely turn red. So C is a soluble salt. But ordinarily, we look at this as a normal salt. Because if it is acid salt, you can have high hydrogen here. Like sodium hydrogen tetraoxide C. This is an acid salt. Or sodium hydrogen tricarbonate 4. All these ones are acid salts, right? So, but that is not what we are talking about now. So now, salt dissolves in water to form a solution, to form a colorless solution. Colorless solution. So C is a soluble salt. Now, when you have this and you add sodium hydroxide in drops, this is a precipitating reagent. Use this thing to precipitate, as I told you, cations, zinc ion. Use it to precipitate zinc. Use it to precipitate. Let me close my table so that I think this board is alright. So that so you use it to precipitate aluminum ion. Use it to precipitate lead ion, zinc ion. So let me just have these ones for now. Just like, okay, now assignment. Which other chloride salt is insoluble? Which other chloride salt is insoluble? Alright. So now lead ion, zinc ion, these ones. So use most of the time use sodium hydroxide to precipitate this. So anytime in your experiment you see sodium hydroxide, your mind should go to these things. Alright. So now, having brought this now, when you add dilute, let me say dilute sodium hydroxide, you have a white gelatinous what? Precipitate. When it is white gelatinous, it means that you have zinc ion and what? Aluminum ion. These are the present. These are the two cations that are possibly present. Now, but this one says, sorry, this is in drops. When you add this in drops, you have a white precipitate. Then, see how I'm recording it. Then, in excess, this is another observation. In excess, what happens? Precipitate dissolves. So, which means these two, when precipitate dissolves, it means that it is still either this or this. It is either this or this. So you can still write zinc ion, aluminum. These two are also what? Present. These two are also present. But now the next experiment is what is going to distinguish, to confirm the very one that is present. Is it zinc or aluminum? Zinc is a transition metal. Aluminum is an amphoteric metal. So it cannot do the same thing that zinc can do, right? So they are metals that have different properties. All right. So let me see if we can manage here. Now you'll be asked to dissolve it in water and divide it into two portions. So you can have, what we may have here is portion A plus portion A to the first portion. Portion A, first portion, or portion plus dilute sodium hydroxide. Then the second portion now, this is question number B, or AII rather. So this is question number AII now. Now solution or portion plus ammonia solution. So aqueous ammonia or ammonia. So when you add ammonia, you are still going to get the same thing. A white gelatinous precipitate. So which means, now sorry, this thing is in drops. In drops. When you add it in drops, it means zinc is present, aluminum is present. Then in excess, I hope you can say this. Then in excess, precipitate dissolves. You will not ask me how come. Here the same thing. What you have here is what you have here. You ask me how come. You know, ordinarily now look at this one. Let me put it here. This portion plus dilute so that you have something like this. So that it drops. Then in excess. So now in drops, precipitate dissolves. In excess now, precipitate in drops. Look at it, the white precipitate. Then in excess now, precipitate dissolves. So as precipitate dissolves, what does it mean? It means that zinc is what? Confirmed. Zinc is confirmed. This is the only, in excess of ammonia solution, zinc will dissolve, but aluminum will not dissolve. Why? Because zinc is transitional. It forms complex ion. Transition elements, they can form what? Complex ion. That's why I like giving assignments. So what is a complex ion? It will form complex ion with ammonia. Zinc will form complex ion with ammonia. Just like copper can form complex ion with what? Ammonia as well. Forming tetraamine copper 2. I don't want to go there so that I don't. So let me not go there. But it is an assignment. So now, so zinc forms complex ion. So what is a complex ion? I hope you can understand that. What is a complex ion? And also, when you have complex ion, what is a complex salt? What is a complex salt? What is a complex ion? And what is a complex salt? Use the comment section, right? Alright. So now, while zinc dissolves, aluminum will not dissolve. Aluminum and lead, where is aluminum and lead? These two, they won't dissolve in excess ammonia solution. So just like in the previous videos I have, the only if you want to now confirm the very one, is it aluminum or lead, what you may have to do is to use hydrogen sulfide. If you use hydrogen sulfide, if it is lead that is present, it will turn black. Lead plus hydrogen sulfide will form lead-2 sulfide. This lead-2 sulfide is what? Black. But if it's aluminum, it will not, the color will not change. Alright, so this is what you may have in the first part, and I hope you can put it well. Write it very well. This is what you may have. So, and the reason for giving you this is for you to study it and study, because I know that many school students and the subscribers I have here, they have been complaining that in their schools they have not been able to be taught well. They have laboratories, but their teachers hardly take them to the lab. So I felt that yes, many of them have asked that this or that topic be taught, And many of them just requested, okay sir, can you help us to teach something on this zinc chloride and this milk, this powder milk. So that's why I decided to like do it right now. All right. Okay, now let's perform the experiment. I've cleaned the board and let's carry out the experiment. Remember, what is this? What is this paper? What is this? And what is this? All right. So let's just add a small quantity of this here. I just decided to use this. Okay, let me add a little more. Okay, so this is water. I dissolve it. So it has dissolved completely like this. You can see it has dissolved completely like this. So nothing, right? So now I decided to use this. So we are managing it. Okay. Let's add it in drops and observe what happens to the milk solution. Wow, it's turning, it's forming, it's forming, it's forming, it's forming, it's forming, it's forming. Look at it. It has coagulated the milk. I hope you can see it. I hope the camera will be bright enough. It coagulated. Show me. It coagulated. Just like it brought it together. Before now it was more, very much like this. Well, it was a solution, but now it's a solid. It's a semi-solid S. So it has coagulated it, has brought it together. It now is even very stronger now. Stronger. It is no longer like solution. It's no longer like solution. It has coagulated it completely. So this is I think for now we have done what we can do. We want you to keep following us, keep suggesting, keep sharing this video to others. Remember, God is just using me to impart knowledge. So if I've made any mistake in any forms, in any ways, we can still make comment because I'm a human being. So may God help us to get to where we are moving to. Thank you very much, Mr. Primus.